Okay, today I thought I'd tape a video about logarithmic functions that we learned about while I was out this week, but then also went over on Thursday in class. So what we really talked about is the reason why we have logarithmic functions, and the reason is sometimes in a problem we need to solve for what the exponent is. And so by having this log function, which is actually a button on your calculator, it really helps you to determine what x is, given b to the x is equal to a. So we went through these in class, but I'm just going to go over them again in case you were absent. So log 9 of 9 is equal to 1. So if you look here, it says 9 down here actually is my base of my exponent. So I'm going to put 9 as the base. My exponent is whatever the answer is over here. And then my answer is 9. So I keep on going. 2 is my base to the 9th power is equal to 512. And those two are not correct. So, and then down here, b to the 0 power, as we learned, anything to the 0 power is 1. So that's writing an exponential form, an exponential equation from a logarithmic form. So now sometimes you're given an exponential equation and you need to write it in logarithmic form. So we just write log, and my base is 3, and I know that my exponent is 5, so I'm going to go ahead and write over there, and I put 243 in here. Here I should add an exponent of 1/2, so I have log of 25 is equal to 1/2 5. So log 20, base 25, 5 is equal to 1/2. The next one, log base 10 of 10,000 is equal to 4. Log base 6 of 10 is equal to -1. Log base A of C is equal to B. So that's how you would convert back and forth. So again, here's some more to practice. My base is 9 of 81 is 2. Log base of 3 of 27 is 3. And then here, the log of x is my base. The 1 is equal to 0. And then over here, I think all of these are similar to what's up here, except for these two in the middle. And so I take 8 to the 1/3 is 2. And 4 to the 1/16, 4 to the -2 is 1/16, and b to the 0 is equal to 1. Okay, turning it over on the back, we went through some more problems. And the one thing on the back that's different than the rest is that you know if there is not anything written as a base, that it's actually base 10. And that's what our calculators put everything as base 10, because that's what our number system is based off of, is base 10. So I'm grabbing a calculator, and I'm just plugging this into the calculator to find the answers. And so I use my log button, and I press log 0.01, and I find my answer is -2. And again, we're looking at the one below. I do log 0.00001 is equal to -5. Okay, then you get over here to the right side, and these problems are a little bit different because they're not in base 10, and I want to use a calculator to figure out what it is. And I can do mental math, but I'm going to go ahead and teach you how to do it with a calculator just in case, because we're going to have to do that in the long run anyway. So it's called the change of base form, and we did take some notes about this in class. So it's called the change of base form. And this is used when I have something like this that's not in base 10. Okay? And how this works is the log of b, which is my base, over the log of a is going to equal to my exponent, which is x. So this looks like log of 125 over log of 5. And at this point, I just use my calculator. Log of 125 over log of 5, which is 3. and 5 to the third is 125, so that makes sense. Again, log of 1/5 over log of 5. So I use my calculator again. Log of 1/5 over log of 5. And that is equal to -1. So that kind of teaches you that. Now, on the next page, we just had some problems that we had to do. And in some we're just rewriting it in logarithmic form. So you kind of did this in class while I was here. I'm going to do a few. I'm going to do, let's see, I'm going to do the middle row here. So log base 4 of 1 is equal to 0. Log base 5 of 125 is equal to 3. Log base 1/3 of 27 is equal to -3. And so you do all the ones on either side the exact same way. They're no different. Down here, these are a little different, and so I'm going to write these out for you because these are where I have to use my change of base form formula. So one of the things that we discussed in class is the bottom is the base. So I know the bottom, or my denominator, is going to be the log of my base, and my numerator is going to be the log of A, which is 81. And then I just plug it into my calculator again, and you will come up with log, not natural log, but log, and we haven't learned about that yet. We will, 81 over log of 3. And that is equal to 4. And so I continue the pattern. I'll write them out for you. You can use your calculator to figure it out and see what they are. So log of 4 and log of 0.25. And this one, this is actually, I do believe, 1/6. So log of 1/6 over log of 36. And I'll figure out that one because that one looks kind of interesting. We'll see what it is. And log of 36 divided by, log of 1/6 is -2. Okay, and that's kind of how you do these problems up here, and you can set them all up. They're all set up the exact same way. There's nothing really special. And we will get, and I will tape a video next week on how to graph the logs.